Welcome to MRU E-Learning, powered by Mallarity University. Today's topic, it will be Introduction to Algorithms and Data Structures, presented by myself, Vijay Krupavatsal, Assistant Professor, CSE, Freshman Engineering Department. Today's agenda, we are going to cover on the concept called Introduction to Algorithm, Properties of Algorithm, Classification of Data Structures, Introduction to Time and Space Complexity, and Conclusion. Let's all know about algorithm once. If we consider the introduction of algorithm, let us consider the concept of student appearing for the exam. Whenever a student appears for the exam, he reads out all the concept what the teacher has provided. Once after reading out all the concept, he will appear the exam where the question paper is provided for them. He is going to look into the problem. By reading the problem statement, he is going to derive his answer. To resolve that answer, he is going to take some processing steps. Now, every time, whenever we have a problem, we need to look into the input and what must be the output. In order to derive the output, what will be the processing steps and what is the thinking capability I need to follow. This is how I'm going to define an algorithm as. Algorithm is a step-by-step process for solving a problem or performing a task. Let us consider the real-time scenario of attendance marking. Whenever we consider the attendance marking, the teacher, once he enters into the room, she starts collecting the attendance. Now, all the roll call list will be considered as an array. We are going to place all the elements in a loop and we are going to perform the counter value. Basing on the present, you increment the counter value for present. For absent, you are going to increment the counter value for absent. And the list will be generated in this particular format. Now, one more real-time example I am going to consider, sharing the work while preparing for a party. Here we have 3 friends and they need to decorate a room with 30 balloons. We have 3 friends, Ravi, Arjun and Karan. Now the problem statement is very clear that the 3 people has to decorate the room. First of all, Ravi will pitch in and what he will be telling is, I will be decorating the room alone. All the 30 balloons, he will be blowing or filling the air into it and decorating the room. It is a very slow process of algorithm. Next, Arjun, what he does is he divides all the 30 balloons among the 3 people and 3 of them is going to share the work and they are going to perform the work. It is a little bit efficient one. And next, Karan comes into the scene and what he says is, let us have some parallel way of executing the concept. 1 person filling the air into the balloon, 1 person decorating the room and 1 person helping in tying the threads for the balloon. So this is how one problem is being subdivided or one problem is provided solution with different kinds of approaches. Wherein the Ravi's approach is a little bit slow and Arjun's approach is somewhat efficient and Karan's approach is parallelism and it is also somewhat efficient compared with the Ravi's approach. This is how we are going to perform the algorithmic representation. Now, whenever we write the algorithm, we are not writing the algorithm for our own self, but rather we are providing a solution for the problem. Whenever we are providing a solution for the problem, we need to focus upon the points called as input. For every algorithm, there must be 0 or more input. Let us consider summing of 2 numbers. Input is 2 numbers that we are considering and we are performing a addition process here. Output, at least one output you need to have for an algorithm. Now, if you are calculating the value for a plus b, that output will be considered as the product, as the sum of a plus b. Definiteness. Steps should be clear and unambiguous. There must not be any kind of unambiguity. You have to provide a clear steps. Finiteness, algorithm must end after limited number of steps. As we have seen in the previous example, we are going to complete the algorithm after a finite number of steps. Effectiveness, every step must be each step must be easy to perform. Next, let us come to the next concept called as Introduction to Data Structures. Why we are considering the data structures after the algorithmic concept? Algorithmic concept is a mathematical approach that you are following to resolve the problem statement. Now, here we have different kinds of examples and representations wherein you can perform introduction to data structures. Why we need to consider the data structure? Data structure is a storage representation that we are going to represent the data without any kind of ambiguity. Now, here I have an example of a supermarket. If you consider a supermarket of DMart, every floor will be organized in a clear way, wherein you do not require any kind of assistant and you can perform your all shopping without any kind of issue. So here we can notice that all the mall will be represented in a sorted way and sorted order, and there will be no ambiguity for the customer to pick any kind of product. Data structure is nothing but organizing and storing and managing the data. We have two kinds of data structure specified here: linear data structure and non-linear data structure. When it comes to linear data structure, we are going to follow certain order in order to specify the data. We are going to maintain the data in a specific order such as arrays, linked list, stack, and as well as queue. When it comes to non-linear data structure, you are going to have some random representation of data. As in the previous example, we have considered a DMart example. Here also, I am going to consider an example for nonlinear data structure. There are two floors wherein one floor is maintaining a parking section for bike, another floor is maintaining for car parking section for that cars. Now here, we are not going to follow any specific order in placing the bikes or cars. Randomly, we are going to arrange the elements. Some of the best practice of algorithms can be effectively implemented using appropriate data structures. Here are some real world examples that we have over here. Phone contact search, we are going to use arrays and list. GPS navigation, we are going to use graphs. Browser back forward buttons, we are going to use stack. Like this, every data structure is going to address the real-time world representation of data, wherein you are going to organize the data and remove the data in an effective way. Let us all come to the concept of time complexity and space complexity. Time complexity is nothing but the time required to execute an algorithm. Space complexity is the memory required to execute an algorithm. Now, let us come to the concept of a supermarket. Once after you collecting all the items, then you go to the billing counter, wherein in the billing counter, you are going to wait for the billing process. Let us say there are heavy number of customers in front of you, then the time taken to execute or perform the billing, it will be more. In the same way, let us consider space complexity. What is the size that is required to execute your algorithm? Time complexity understanding. Whenever you write or design any algorithm, you have to undergo certain steps. It follows clear and efficient way of executing the algorithm. In this way, we are going to derive time complexity under best case, worst case, and average case. Now, basing on the example, the situation, every customer has one item, the cashier is fast, there will be no delay in that particular counting or performing the billing operation. So here, the time complexity will be big O of n. Now, next comes to the worst case. Every customer has m items. There is some expensive per item steps. So here, the count that is going to be taken will be big O of n into m. Let us say n is 50 and m will be 100. Totally 5,000 operations you are going to perform, which is nothing but a worst case. And final one will be average case. Customer have different items, use the average, k average. Then the items, it is going to perform the operation, which will be appropriately up to 1,000 operations. Let us all understand what is space complexity. Space complexity is nothing but the amount of space required to declare the variables in your algorithm. Here also we are going to specify the scenario using best case, worst case, and as well as average case. The amount of variables is less, then it will be considered as best case. And if the worst case, each customer has m items, then it is the space, it is going to be considered as 5,000. And average case, each customer has an average item list, then the space required will be almost all 1,000 storage units. Asymptotic notations. It is a mathematical framework that we are going to represent our algorithm. We are going to measure our algorithm speed basing upon the asymptotic notations. It is totally a mathematical representation wherein you are going to perform the space and time complexity as the input size. Asymptotic notations. It is a mathematical framework used to describe the growth rate of an algorithm, space and time complexity. We are going to represent the asymptotic notations as big O, omega and as well as theta notations. Let us consider the representation of the range of your asymptotic notations. Whenever you specify the asymptotic notations, you are going to represent the smaller to the largest. It is listed as constant time, logarithmic time, square root, linear, as so on. We are going to continue. Let us consider the scenario of car traveling. When we are traveling from distance from source to the destination, there are d kilometers, and the speed required, basing on the speed itself, we are going to reach the destination part. We have the asymptotic notation representation as big O, upper bound. The meaning is maximum time the car might take to travel d kilometers. If there is traffic, the car will not take more than this much time. Maximum speed is 60 kilometers, distance is 120 kilometers. Appropriate time that you are going to take is 2 hours. Then, big O is considered as the upper bound. F of n is big O of g of n if there exists a constant such that f of n is less than or equals to c of g of n. The big O notation represents the upper bound range limit. Omega notation, lower bound, the minimum time the car must take to travel d kilometers. Even if the road is empty, the car cannot be faster than the time. The maximum speed it will be 120, distance is 120, totally 1 hour it is going to take. The time growth linear with distance. Omega notation, it is a lower bound representation. F of n is omega of g of n. If and only if f of n will always grow faster than c of g of n. Theta notation, a tight bound. Exact expected time growth, both lower and upper bound. On average, it will take around the time. Average speed is 50 kilometers per hour, distance is 120, and the time taken will be 1.5 hours. Both best and worst time roughly proportional in theta notation. Theta notation, a tight bound, f of n is g of n if there exist two positive constants c1 and c2. The notation, meaning and speeding analogy, the time for 120 kilometers, it is listed out. As you can see, big O is represented as upper bound, maximum, omega is represented as minimum, theta is represented as average representation. The time complexity that I am going to consider in order to check the student availability in the classroom. Let us say Rahul is a student available in the classroom. Rahul, if he is present in the first list, then automatically the time taken will be omega of 1. If Rahul is present in the last list, it is the time taken will be the worst case, big O of n. Average case, if the Rahul is in the middle of the list, he is going to be theta of n. Conclusion. Every algorithm provides a clear step-by-step representation of solving a problem. And whenever you design any algorithm, you need to focus on the time complexity and space complexity to provide the efficiency of the algorithm. Thank you.